Now we're going to take a look at using the Common Language Runtime in .NET to implement SQL, our structured query language, and interface with databases. So I'm going to make a new project. And again, we'll keep this one simple. It's just going to be a Win32 console project. And we'll call this SQL1. So it's a Win32 console application. I'm going to go to application settings. I'm going to make a very simple project, so it's going to be empty. And then we just want to add a CPP source file and include the common language runtime. So I'm going to add a source file. Okay, this will be our SQL project. First, to create an application that uses the CLR and .NET Framework in Visual Studio, right-click on Project Properties and select Configuration Properties, General, Common Language Runtime Support, and then select Common Language Runtime Support /CLR. And I'm going to right-click on the project as soon as my computer catches up here. And let's go into Properties. And I want to come down to Common Language Runtime Support right here, or the CLR. And I'm going to set it to Common Language Runtime Support, or /CLR. Okay. And to save time, I've pre-coded the project. So this is the code that we'll want to enter into the project. And all the source code's on the website, but we'll go over it here as well. And you'll also need an Access database for this example. And Access is not the most efficient or the fastest database product out there, but most people have it. If you have Office, you probably have Access, and it's portable and small, and it's easy to create one. So we'll be using that. Okay. So let's take a quick look at our project. Next, we need to include system DLL and system data DLL with the using directive. Then we need to use these namespaces: system, system data, and system data OLE-DB. Also, before we test it, I just want to make sure that I copy it to the appropriate folder. So in this case, I was working in this project folder, and the kind of connection string I'm using is a relative path connection string. So I'm not specifying an absolute path anywhere. So all I have to do is just make sure that I copy my Access database file, the .mdb file, to the same subdirectory that my binary executable is being compiled in. And the way Visual Studio does it, if you look up here on my path, it's usually like the project name, subdirectory of the project name, subdirectory of the project name, and then it's the parent directory of the debug folder, because the debug version by default in Visual Studio. So I'm just going to copy this, right? I'm going to go out here and I'm going to go to this new project folder that we created for this example, and there's SQL1 and SQL1, and I want to go into SQL1, and then here's my debug folder, right? So here's the parent folder, just showing you, how the path is set up. This is where I want to put my MDB file so that my connection string can connect to the relative path and get to that file. Now, in the compile project, when I compile it, it would need to be in the same folder as the binary executable. You understand? I just put the exe file and the MDB file together, and they'd be all set. But when I'm testing it in Visual Studio, it should be in this path here, right, in this folder here. So we're going to go ahead and run the program now, and let's see if we can connect to our database using our relative path connection string. All right, here's our first record, ID, and then quantity, in this case field name, and then price, and press enter to continue. In addition to implementing the Common Language Runtime, we need to implement System DLL, Dynamic Link Library. Remember, a Dynamic Link Library or DLL is like a function suite, or a suite of functions that can be shared by multiple applications. And in this case, we need this, we need to pull these DLLs in to be able to interface with our Access database and to run SQL commands and things like that. So System DLL and System Data DLL. And then these are our namespaces: system, system data, and system data OLE-DB, which is short for Object Linking and Embedding Database. All right, so an OLE is an Object Linking and Embedding OLE-DB database. Okay, we have one prototype, and that's pause, and it's pretty simple. All it does is, it simply displays pause, press enter to continue, calls the function readLine on console, It clears the screen when we're done. Okay, and then everything else happens inside of main. This first one's going to be a very small, very simple program, just to kind of introduce the idea of interfacing with databases, when using the common language runtime. And I threw up here in comment text, there's just two ways we can do this. If you want to list the absolute path, all right. In other words, if it were on the D partition, and then I do like a sort of a double backslash, and then the parent directory, and then subdirectory, 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 database name. That's fine, you can do that, but the problem is it doesn't make a very portable program. Once you compile it into a binary executable, if you were to put it online or move it around or copy it from one server to another, it's not going to be the most versatile. You're going to end up having to change this connection string every single time. And on the other hand, you could also choose a relative path instead of an absolute path, in which case, in this example, it's just going to go open it up in the same directory as the binary executable. That's kind of my preference, but there may be reasons to utilize both methods. But this is just an example of an absolute path and an example of a relative path. Okay? But either way, we've got to provide a connection string. And before we can provide a connection string, we have to create an OLE-DB connection. To connect to and manipulate a database via OLE-DB, first, create a managed instance of an OLE-DB connection with the caret. Second, specify a connection string with an absolute or relative path to the database and an appropriate driver for the type of database being connected to. Third, add try and catch blocks to handle an OLE-DB exception. Fourth, call the open method on the OLE-DB database connection. Fifth, build a SQL string to query against the database. Sixth, build an OLE-DB command object and pass your OLE-DB connection object and SQL string to its constructor. Seventh, build an OLE-DB reader object and assign to it the return value of the executeReader method called on your OLE-DB command object. Eighth, call the appropriate OLE-DB reader method. For example, to read through an entire database, you would use read inventory read while read evaluates to true if read inventory was an instance of an OLE-DB data reader. Some other useful OLE-DB reader methods are getFieldType, which gives the field type of the records column, getName, which gives the column field's name, getInt32, which reads an integer value from the database, getDecimal, which reads a float or decimal value from the database, and getString, which reads a string from the database. These methods take the column number as an argument. Finally, when you are done reading from and manipulating the database, close your OLE-DB reader and OLE-DB connection objects. So, to start, by using these dynamic link libraries, these DLLs, and putting them in, and by pulling these namespaces in, we now have access to an OLE-DB connection object. And you see the caret there. So remember, that means that it's like a pointer, but it's a managed object. So it implements garbage collection, things like that. All right, and the same thing, GC_new is sort of like new, but unlike the ANSI new, this designates that our instance of the OLE-DB connection, or a pointer to it, is a managed object, a reference to a managed object. So think of that caret like a pointer, and think of GC_new like new, but with the understanding that in the common language runtime, or .NET, that means it's a managed object. Okay, so that means that database underscore connection would then be a pointer to a new OLE-DB connection object built on the heap or the free store. If you're looking at that from an ANSI point of view, an old C++ or a standard C++ ANSI point of view, my personal preference, but my philosophy, or my belief is that we need many tools, not just one. And the common language runtime and .NET is one of many tools, and there are good reasons to use them sometimes. So let's not, even though we may have a certain preference for a certain flavor of C++ or certain, why not, look at all of these different ways of doing things, and then maybe some ways work better than others. But okay, so I guess I'm getting too chatty here. All right, so we have a pointer. Let's just call it a pointer, database connection to an OLE-DB connection object. Once we have that, we can set up a connection string. So when we've built that, now we can come down here and we can call the method with the arrow. Remember, there's end direction here, so no dot operator, but an arrow. And database connection was our OLE-DB connection object. We call connection string, and we're going to set that data member. And in this example, I'm using a relative path. It's just going to be in the same directory that the binary executable is running inside of when we compile the project. Once I've done that, then inside of a try block, I want to go ahead and open my OLE-DB connection object. Okay, so my connection string was set up. I have a pointer to it. I built the object. Connection string set up. Now I'm opening it. Like any I/O process, just like when we're doing sequential and binary file access with ANZ and with .NET, it should be inside of try and catch blocks, because anytime you do I/O, potentially things can go wrong. So if something goes wrong and we cannot connect to the database and we cannot open it, then it would go down to the catch block, and we would want to catch an OLE-DB exception. Again, sort of a pointer, a managed object with the caret there, a problem, and then we would use that, and we could just kind of print a stack trace like you would in Java. All right. But if not, if everything goes okay, then that means we could open. We were able to open and connect to our inventory.mdb access database file, and now we can actually use some SQL with it. All right, or Oracle database or whatever. I mean, you guys can do anything with SQL, but we're using access in this example because, like I said, it's portable, it's small, and most people have it on their laptops, on their computers. It's readily available, so you'll be able to, if you're going through this and kind of learning a little .NET and the common language runtime, you'll be able to create it on your own. So we open it, and then once we open it, we're going to set up a string. It's just a pointer to a string. It's a kind of .NET CLR string. And if you're not familiar with SQL, then you may want to familiarize yourself a little bit with the syntax. It's a very simple language. It's even simpler than HTML. You can pick it up in 10 minutes. I have a couple pages on the website, and good grief, there's got to be 10,000 other websites out there devoted to SQL and books and whatnot, all free for the for the learning, for the taking. But essentially, we're saying select, and you could think of this command here like almost like dragging the mouse. Like I'm dragging my mouse and I'm selecting. So we're saying select. These are field names: ID, name, quantity, price. So they're field names separated by commas. So select these 4 fields, and then this would be the object, right? The source of the object that you're selecting the fields from. So in other words, this would be like the class. Inventory would be like if this were pure, unadulterated C++ and we weren't using an access database file or SQL, then we would have created an inventory class. And this would be field data, private data inside the inventory class, and we would be calling public accessors to fetch, to get that data and return the values. So essentially that's what we're doing, but we're doing it with SQL. We're creating a SQL string here, okay? Once we do this, we had to create an OLE-DB connection. We had to assign it a connection string to go out there and find some database object, in this case an access database file. And it's a relative, not an absolute path, so it's a little bit more forgiving if you move it around. And we're going to open it, and after we open it, we've created a SQL string, and now we just want to pass that SQL string in. And the way to do that, now we have to create an OLE-DB command object. You can call it whatever you want, banana, if you preferred, but we're going to call ours command inventory. And again, there's the caret, so it's a managed object, a pointer, and there's GC new, so it's building on the heap or the free store, but it'll be garbage collected. Okay, so we're building a new OLE-DB command, and when we do, in the constructor of the OLE-DB command object, we're going to pass in our SQL string here. So in other words, select these 4 data fields from this class or table, records, tables. You can use database terminology, you can use class terminology, interchangeably actually. And then the name of our connection object. So our connection object was built, assigned a connection string, we generated a SQL string, and now we're building an OLE-DB command object, and into that we passed both the SQL string and the database connection that we just created. Now we can actually begin to do something with it. There's only one more sort of intermediate step, and that is if we want to display items and read items from the database, we're going to need an OLE-DB data reader object. Alright, so once again, let's go down the list. There was an OLE-DB connection object that we built, And then on that OLE-DB connection object, we set up a connection string, and we opened it. We called the open method inside of try blocks. We built a SQL string, and then we instantiated an OLE-DB command object, passing in our OLE-DB connection object and our SQL string. And now finally, before we can actually plug it into a loop and pull the values out, like we've done with pure C++ and ANSI C++ and other methods, we have to build or instantiate an OLE-DB data reader object. We'll call it reader inventory, and all we have to do is we're going to take our OLE-DB command object that we passed the SQL and the connection object into, and we're going to call the function or the method execute reader. And the value that that method returns will then be assigned to read inventory. All right, so sort of a four-step process, almost like chaining the streams in Java. If you look at like sequential file access and things like that. But in this case, this is SQL and database access, not sequential file access. Okay, so we're going to set up a counter and start it out at 1 just to count up our records. Remember, a record's a row, and the variables, the data members, are the fields, they're columns. If you want to think in terms of rows and columns, or you can think in terms of an instance of a class, and data members. Again, they're interchangeable. They mean the same thing. You could argue over semantics, but essentially, fields or columns in an Access database are private data members in a class. And the actual table itself could be considered an entire object, or each table could be considered a class. And then each of those tables would have data members and methods associated with it. You see what I'm saying? So that may shorten the learning curve, because you can kind of take what you already know and build a relationship between standard ANSI access and what we're doing with SQL and OLE-DB command and connection and data reader objects. Okay. Anyway, once we built that and we've chained everything up, then we're just going to go call the read method, and we're looping the sentinel value is when we get to the very end of the database. So we're going to keep reading and reading and reading until our OLE-DB data reader object no longer returns true. Which in this case, we're just going to go down every single row in the database, every single record, and read them. Again, take just a moment and review some of the OLE-DB reader methods. Now let's take a look at some of the OLE-DB data reader methods. Okay, so in this example, we're just using an integer to count the records. And then we're going to go down and call some methods. All right, we have to convert it to a string to display it. But nothing really happens with our database reader object until we get down here to ID. And this acts as the primary key in the Access database. And I'll open it up and we'll look at it in just a moment. But I selected 3 different methods that you could call via the arrow on your OLE-DB data reader object. So get field type, which is an accessor that will simply return the field type. It's type specific. It could be numerical, it could be Unicode or ASCII text, currency, something like that. And that would return the field type. Get name, which would return, think of it like the variable name in a class you might write. Or in this case, if you were in design, view, and access, that would be the, the field name. Okay, so you could think of fields as columns, and the collection of fields altogether you can think of as a record or rows in a database typically. Okay, so that's get name, and then finally, this would actually get the value stored in the variable, or in the field name. And it's type specific, so if it were numerical, a whole number value would have to call get int32. If it were string, get string, and if it were, something like a float or a double, decimal values, we call get decimal. All right, so there are different methods we would call on the reader object itself. This sort of acts like an array subscript value. Just like that would designate, elements in an array, but in this example, we're designating fields. Or you could think of this as maybe columns in the database. So we're going to get the field type on the first column, and the name, and the value stored. Then we move on to the next field. Field type, name, and we have to call get string instead of get int32 because in this example, the type of data stored there is string data, not numerical data. All right, so that was the first field, that was the second field, now we're at the third field. We're going to get the type and the name and the value stored there, and it's numerical, so it's get int32. And then finally we're going to take, grab the last field, the fourth field, but it's off by 1 because it starts at 0, just like an array. And we're going to call get field type, get name, and get decimal because it's decimal data. This is just from a quick little easy inventory database I made an access to just hold information, for computer parts. So let's open it up and look at it, and we'll relate it to the code, so to speak. I'm going to open it up. I'm going to open this up in Access 2010. All right, and we'll open it up, and these are the records, the values that are stored there. So think of these columns as variables in a class, right? That would be like your private data. So we'd have a private data, private int ID, and we'd have a string or a C string name that would hold string data, and we'd have another integer quantity, and then we might have a float or a double to hold price, so to speak. So you can relate it to what you already know, and it's really the same, just an extension or an extrapolation of what you already know, if you're not familiar with SQL and Access and Oracle databases, things like that. But so think of it like that. Now let me open this up in what Access calls design view, and instead of seeing the values stored in the variables, we can see like the data type. So we're going to go switch over to design view. And this would be, pretty much the variable name, and then in the declaration and initialization of a variable and a class specification, this would be the data type. Okay, so auto number, basically it's an integer. That's just string value text. That's just a plain old integer whole number value, no decimals. Now currency, on the other hand, that would be like a float or a double. It would have a decimal portion to it. Not just dollars, but dollars and cents, so to speak. So looking at that Access database, you can kind of get a feel for why we call these different methods. You understand what I'm saying? In other words, get field type, well, that's just an integer. The name it's going to return is ID, that's the name. And this is, auto number, it's pretty much just a flat out integer, okay? Long integer. So what we need to use is get int32. The next field value, well, let's take a look at it. The next field is name, but it's just text. So it's a string value, okay? So to pull it from the Access database, we can't use get int32. We need to use get string. That's the proper method for returning a string. Now, what's the next field? Next field, we're using get int32. And again, quantity, that's just a whole number integer value. Okay, no decimals there, so we're going to use get int32. And the last one, price. There is going to be a decimal portion to price, right? And that's because it's in the currency format. And if you look at the records, the records, see, there is a decimal portion there stored there as far as values. And we don't want to truncate or lose anything, so we're calling get decimal. All right. So you can that kind of loosely explains how everything works. And then let's run it and we'll take a look at it. And then in the next example, we'll actually look at how to build different SQL strings and do things like search for items from a database, remove items or add items to a database, and do other things, with the data using SQL strings. Now again, all that's in a try block. Remember our catch block down here? We just catch an OLE-DB exception, and we'll print what went wrong in a kind of like a Java stack trace there if something went wrong. And then we pause, and then we'll end. Okay. So let's run it. Now I don't want to create an access violation. You don't want to have your Access database open in Office and then also try to open it with a C++ program. A lot of times it will generate a lock file, or you can have access violations and things. So we're going to completely close it down, and then we're going to run our program out of Visual Studio. Note, make sure your Access database or .mdb file is in the appropriate directory that matches your OLE-DB connection string path, whether relative or absolute. Also, before we test it, I just want to make sure that I copy it to the appropriate folder. So in this case, I was working in this project folder, and the kind of connection string I'm using is a relative path connection string. So I'm not specifying an absolute path anywhere. So all I have to do is just make sure that I copy my Access database file, the .mdb file, to the same subdirectory that my binary executable is being compiled in. And the way Visual Studio does it, if you look up here on my path, it's usually like the project name, subdirectory of the project name, subdirectory of the project name, and then it's the parent directory of the debug folder, because the debug version by default in Visual Studio. So I'm just going to copy this, right? I'm going to go out here and I'm going to go to this new project folder that we created for this example, and there's SQL1 and SQL1, and I want to go into SQL1, and then here's my debug folder, right? So here's the parent folder, just showing you, how the path is set up. This is where I want to put my MDB file so that my connection string can connect to the relative path and get to that file. Now, in the compile project, when I compile it, it would need to be in the same folder as the binary executable. You understand? I just put the exe file and the MDB file together, and they'd be all set. But when I'm testing it in Visual Studio, it should be in this path here, right, in this folder here. So, testing 1, 2, 3. So let's just run our project to test it now. And let me bring the console over here, and I'll make this a little bit easier on your eyes, hopefully. If I give it like a light colored background, and we'll give it some dark text there. Alright, so here's our first record. Remember, that's just an integer being converted to a string literal. But now, at this point, we're actually using our data reader object, and we're accessing that MDB file, the database, using our SQL string. Okay, and remember the SQL string said select 4 fields. We'll go through and go back up here and grab our SQL string. Alright, select ID, name, quantity, and price. Okay, so look at that. ID, name, quantity, and price. And those are the field names. See the method here? Get name, get name, get name. It's just an accessor. Now the field type, let's look at the field type. All 4 of those is field type. So let's see what the field type is. System int 32, so what was the method that we used? Get int 32. See? This type was what? System string. So the method that we used was get string. Alright, what was this field type on the next one? Int 32, so we called get int 32. And then finally down here, system decimal, so what do we call get decimal? Is it starting to make sense? I think so. I think you'll be able to relate this fairly quickly to everything you've learned so far about ANSI C++ and just kind of the old standard, stream operator and the way that works and that kind of file access. It's just an extrapolation or an extension of the same idea. The fields in the database are simply variables. Okay. The columns, if you will, that's the collection of private data that would be encapsulated inside of a class. The rows, if you will, are the instances or instantiations of that class. They're actual objects built from that class that have separate, values. Each of them have their own set of columns or their own set of data members, so to speak. So it's just an extension of that same idea. And then, all right, that was all the first record there. All right, so fields 0, 1, 2, and 3. In other words, columns 1, 2, 3, 4 in the database. And then what happens? We're in a while true loop. So then we go to the next record, the next row. Read that. Then the next record, the next row. Read that. Then the next row, next row. Well, at the bottom, we're calling pause. And remember, pause clears the screen after we hit enter. So let's watch and see what happens. And here's our values. And if you wanted to check our, I'll tell you, I can't open this and access an Office at the same time as I'm accessing it from Visual Studio. That would not be a good idea. But if you go back in the video or if you look at it, these were the values stored there. That was the primary key 1. That was the string value power supply. In this case, the quantity was 100 and the price was 50. Okay, so I'm going to cycle through the next few records. Okay, there's record 2, quad-core CPU, so forth. Record 3, quantity, 1 gigabyte dumb memory. Hard drive, 1 terabyte. Record 4, record 5. And now we reach the end of our while true loop. All right, remember, while is equal to true, well, when we get to the very last row, right, the last record in the database, it will no longer be true. That's the sentinel value to bust out of our while true loop. So if I hit enter again, boom, we're done. Okay, so just an example of using the common language runtime in .NET to access to utilize SQL, structured query language, and the OLE-DB objects to access a simple access database.